Assalamualaikum warahmatullahi taala wabarakatuh. Sebelum program kita diteruskan, saya menjemput Hafiz Amiruddin untuk bacaan doa.
Al-Fatihah. A'udzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi alamin. Ar-Rahmanir-Rahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Shiratal mustaqim. Shiratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Bismillahirrahmanirrahim. Allahumma aftah 'alaina hikmataka wanshur 'alaina min khazaini rahmatika ya arhamar rahimin. Rabbi syrah lana sudurana wa yassir lana amrana wa hlul min lisanina yafqahu aqwalana. Ya Allah, ya Tuhan kami, Kau pemudahkanlah pembelajaran kami pada malam ini, ya Allah. Berilah segala ilmu yang diajar oleh Cikgu Intan berguna pada semua pelajar sekolah Tuanku Abdul Rahman, ya Allah. Sallallahu ala sayyidina Muhammad wa ala alihi wasallam walhamdulillahi alamin. Allahumma salli.
Amin, 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 Rabbal Alamin. Seterusnya, saya menjemput Cikgu Zita sebagai Ketua Panitia untuk memberikan ucapan.
Assalamualaikum warahmatullahi taala wabarakatuh. Yang saya hormati Puan Norizah binti Muhammad Sabri selaku Guru Kanan Sains dan Matematik Sekolah Tunku Abdul Rahman. Yang dialu-alukan Cikgu Intan Zarina daripada Sekolah SMK Sultan Yusof Batu Gajah. Seorang guru yang saya kira agak aktif dan hebat juga ya. Dia dari segi dia punya pengalaman dia ya. Dan Cikgu Hafizul Marwan dan seterusnya anak-anak star yang Cikgu kasih sekalian. Jadi Cikgu di kesempatan ini nak mengucapkan terima kasih lah ya kepada Cikgu Intan kerana sudi menjadi tetamu jemputan ya untuk program Teknik Menjawab Kimia Kertas 2. Kita fokus kepada bahagian esei lah. Jadi Cikgu ni mewakili Ketua Panitia lah ya, mewakili Ketua Panitia mewakili Panitia Kimia dan juga Sekolah Tunku Abdul Rahman mengucapkan jutaan terima kasih lah atas kesudian Cikgu Intan untuk menjadi penceramah. Dan diharapkan ya pelajar-pelajar star ya, apa yang Cikgu harapkan anak-anak star ni dapat memberi tumpuan sepenuhnya lah sepanjang program ini berlangsung, dan diharapkan juga ya dapat memberikan suntikan semangat ya supaya dapat sebagai persediaan lah untuk peperiksaan percubaan selaras SBP itu pada 8 Oktober nanti. 8 November nanti ya. Jadi cikgu rasa program Road 2A+ ni bukan sekadar untuk melahirkan pelajar yang dapat keputusan straight A, tetapi lebih daripada itu lagi lah. Cikgu mengharapkan kalau boleh insya-Allah ya semua boleh skor A+ lah untuk 44 orang ni sepatutnya. Jadi tanpa membuang masa lagi, cikgu serahkan kepada Najmilah selaku MC pada hari ini. Sekian, terima kasih.
Terima kasih diucapkan kepada Cikgu Zita atas ucapannya tadi. Saya teruskan lagi dengan sedikit perkongsian mengenai latar belakang penceramah kita pada hari ini. Cikgu Intan Zarina binti Zahidi, antara tenaga pengajar di SMK Sultan Yusof, Batu Gajah Perak merupakan Jurulatih Utama Kebangsaan di SKP Kssm Kimia, Jurulatih Utama Negeri Format Instrumen SPM Kssm Kimia, Hakim STEM Online Challenge Kebangsaan 2020 dan juga penyampai di DET TV. Jadi, saya berharap kita semua dapat memanfaatkan masa yang kita ada ini. Tanpa berlengah lagi, saya serahkan pada penceramah untuk meneruskan program kita.
Terima kasih. Terima kasih kepada host, kepada everyone in star lah basically kerana menjemput saya hari ini. InsyaAllah saya akan cuba kongsikan apa ilmu sedikit yang saya ada ni dengan pelajar-pelajar star lah. So kita terus pergi kepada the handout. So saya rasa you dah dapat dah handout ini. This will be done in English, so hopefully semua orang okay lah. Just in case you ada any questions, you boleh terus je just unmute your mic or tanya dekat dalam chat tu lah. Okay, so kita go through redox. Okay, if we look into redox ni, since KBSM days sebelum ini pun, it is topic that is orang kurang suka. But then the main thing of this topic sebenarnya adalah this page. Okay, so if you can understand this well, then you are able to answer practically all redox questions. So untuk to identify oxidation or reduction reaction itu, there are 4 criteria, but then for exam purposes, mostly it involves transfer of electron and change in oxidation number. So this one ada, but it's seldom. Okay, so as we know, untuk oxidation, when it involves oxygen, you gain reduction. So there are so many mnemonics that and my friend. So number is
Intan, suara tak berapa clear.
dengar tak?
Ke cikgu punya line? You all clear tak?
Clear.
Cikgu.
Dengar tak suara cikgu Intan?
Dengar jauh.
Dengar macam jauh Intan. Tadi clear, mula-mula tadi clear, very clear.
Saya cakap kuat je. Kalau saya cakap kuat boleh dengar tak? Jangan dia jauh juga.
Rasanya cikgu terpaksa guna mic daripada iPad kot. Dia baru clear. Macam daripada ada device tu, suara dia punya macam audio dia tak tangkap clear lah. Cikgu boleh tengok dekat iPad, tekan butang unmute lah, baru dia ni.
Okay, boleh dengar.
Okay, clear, teruskan.
Okay,
Okay.
clear.
Okay, so tadi ni, the way to remember is you have so many mnemonics too, you follow je lah whatever that you have been using, but one that was given to me is Leo says grr. Leo tu is the lion, so that's why it says like that lah. So Leo is loss electron is oxidation. Okay. Grr ni gain electron is reduction. Okay, so Leo says grr. Okay, so for you to remember lah. Okay, and then for the change in oxidation number, when there is an increase in oxidation number, if I use symbols like this, can you understand? Okay, oxidation number increase means it's oxidation. Oxidation number decrease means reduction. Okay. So that is the main thing of this topic lah. Bab ini main thingnya. Okay. So we go terus kepada the questions that involve that. Okay. So kita pergi dulu kepada this one. if you can look into your handout tu, we'll be going macam back and forth sedikit untuk the handout. Sorry for that. Sebab saya susun the handout based on the SPM year. So if you can look dekat page yang ada SPM 2013 yang ada this one. Okay. So this is one of the easiest lah kalau you look at the question point. The following are the formulae of two compounds. Based on the formulae, they have given you MgCl2 and also Fe2O3. Okay, so state the oxidation numbers for magnesium and iron. So this one, I don't think anybody has problem for this. Since this is an essay question, so you must remember that you are answering this in a test pad. Okay, therefore, one thing I want to remind you is if your handwriting is small, please enlarge it. Number one. Number two, if your handwriting is so big, then leave a line for every single one that you have written. Maksudnya, you have written something here, leave a line, then only you start writing. Why? Sebab otherwise, your handwriting will be all crumpled up together tau. And you must remember that nowadays it is online marking. So the scanning, the everything will affect if tak nampak your handwriting to itself kan. We don't want that to happen. So we try as much as possible to reduce those condition or situation. Okay, so going back to this. Okay, so untuk chemistry, chemistry is a subject that when you answer essay questions, it is precise, it is straight to the point. So you don't have to put lengthy words. So what you can do here adalah, number one, you will write oxidation number of magnesium. Okay. Oxidation number, yang ini ramai pun orang tak aware that oxidation number is for elements. So that's why kita tak sebut oxidation number of Mg2+. Sebab yang ini kat sini we assume that this is Mg2+ kan, this is an ion. Tetapi when you want to mention its oxidation number, it is always for the element. So it is oxidation number of Mg. In this case, for this one is +2. Okay, so oxidation number starts with the symbol, then the number. It's terbalik, then charge. Sebab what happens in SPM is ada orang akan tersilap. What they will write is 2+. If you were to write this way, then you'll be getting it wrong. It has to be the symbol first, then only the number. Okay, clear code. How to get that? Okay, for macam magnesium, its charge untuk ion, magnesium ion is Mg2+ kan? So its charge tu follows, oxidation number dia follows its charge. Cuma the way you write it je different. Boleh ke? Did I confuse you?
Can.
Okay.
Yeah.
Alright. So then if we look into oxidation number of iron. Fe. Macam tu je. Okay. Then we see here, kalau kat sini, we look at this. This is actually Fe3+ with oxide kan. So from here, we can see that the charge is 3+. So oxidation number of this ion is +3. Okay. And then they ask you to name the compounds. Okay. To name the compounds, number one, you just write like that. And this will be magnesium chloride. Okay, when they ask you for the name, be careful of the spelling. At times, kita can be a bit careless. Sometimes the normal things that we spell pun jadi salah. So avoid that lah. We reduce as much as possible careless mistakes. Okay, Fe2O3. Okay, iron being a transition element, so we have to have the oxidation number in bracket kan. So this will be this will be iron 3 oxide. Okay, so I think this one tak ada problem. This is an easy question. So insyaAllah okay kot. Okay, then if we look, is there any question to this? So
Saya nak tanya,
ya saya.
kalau kita macam tengah rushing dalam exam, so number tu kita buat short form tulis NUM je boleh tak?
This one they don't mark you for this. Ini they don't mark you for this. It's just kita nak bagi the examiner understand that you are referring to the MG punya oxidation number kan. Ada je dalam SPM orang tulis macam ni, MG positive 2. Boleh je.
Terima kasih cikgu.
Tanya,
Ya.
yang ferrum trioxide tu kan, kalau kita letak nama dia ferrum instead of iron boleh ke?
Ferrum trioxide you put.
Ferrum.
Boleh.
Boleh.
Ferrum is a
Acceptable lah.
Latin name, boleh.
Okay, thank you.
Okay. Okay, any other questions? Okay. Alright, so and then kalau kita tengok kat sini, if we can flip through SPM 2014, this is partly the 1.1 and partly 1.5. So kita tengok dulu. Dekat sini, the question starts with Table 3 shows the information for 4 sets of experiment to construct the reactivity series of metals. Okay, so they have given you 4 sets. Okay, carbon plus iron 3 oxide, grey solid formed. Carbon plus oxide of X, brown solid is formed. Set number 3, carbon plus magnesium oxide, no change. X plus iron 3 oxide, no change. Okay, the first question, set 1 is a redox reaction. What is the meaning of redox reaction? Okay, so kat sini, what will your answer be? Anyone? Adakah? Ke saya je jawab semua? Nanti sekarang you will be bosan.
Reaction.
The reaction?
Chemical reaction where oxidation and reduction occur simultaneously.
Yeah. Reaction that involves, betul? Reaction that involves oxidation and reduction that occurs simultaneously. Okay. Kalau you rasa to spell simultaneously tu difficult for you, tak payah je simultaneously. It's just that it is in the textbook. Kalau you say occur at the same time pun, it means the same thing and it is accepted. So jangan worry yourself. So what you can do is, kan, kadang-kadang the other words yang bukan the istilah yang you worry about kan. So kita ubah so that kita can write it comfortably. Reaction that involves oxidation. This oxidation and reduction ni kena spell properly lah. That occur. You boleh je simultaneously. Tapi kadang-kadang ini yang kita salah je kan. Kita tak mau itu yang merisaukan kita. Kita boleh tukar kepada that occur at the same time. Boleh. They will accept both answers. Okay. And for set 1, ini satu lagi. Bila there are things like macam ada banyak set, so you don't want to be careless. So you highlight whatever that is important. Now, this question A ni involves set 1. So kita hanya refer to set 1 je dulu. Okay. So then they are asking for the chemical equation for the reaction. This reaction occurs because dia ada change, ada observation tu maksudnya the reaction occurs lah. So we have carbon, C, iron 3 oxide. Tadi kan ada iron 3 oxide. So macam tu. Okay. Then grey solid is formed. Okay. Grey solid ni apa? So it is iron lah kan. Plus carbon dioxide. Okay. So this will get you the first mark. The formulae of the reactants, each reactant and each product. You have all 4 formula correct, baru you dapat the first mark. Okay. Then the second mark will be balancing the equation. Okay, how do we balance the equation? Kita balance the iron first, So 2 here. So that will make you have 4 here. Lepas tu, kita nak letak 3 for the oxygen, so 3 here. So once you dah balance the equation, then you will get the second mark. Okay, so most chemical equation in chemistry will allocate 2 marks for you lah. Cuma at times dia ada 1 mark sahaja kalau it is an easy equation. Okay, then they ask for, nampak tak? State the change in oxidation number of iron. Dia sebut iron, dia tak sebut pun iron 3. So oxidation change in oxidation number. When they use the word change, that means it has to be from asal, from original until it change to what lah. So originally, okay, kat sini, this one, okay, this one, the oxidation number of iron here is positive 3. It changes to yeah. So positive 3 to 0. Like that. Okay. Kalau tak sure pun, ni dekat nama dia ni, dekat the name ni that helps you a lot lah. Lepas tu kalau you tengok dia ni sorang-sorang ni, means it's an element, so oxidation number dia is 0. Okay. Okay. So then they ask you which substance undergoes reduction. Okay, still referring to the first set. Which substance undergo reduction? Okay, so yang mana satu undergo reduction?
Serum, iron.
Okay. That one tak boleh jawab gitu. Why? Okay. Because iron tu dekat sini tau. If you answer iron sahaja, then it is referring to this fellow. And yang the one undergoing oxidation or reduction, it has to be those and in the apa ni?
Reactant.
Yeah, dekat reactant. So which one exactly?
Iron 3
Ferrum oxide.
Yeah, iron 3 oxide. Yes. Fe2O3, iron 3 oxide, ferrum 3 oxide. Tu. That one. So be careful. This is that's why I purposely ask you that sebab memang akan ada orang yang akan jawab iron je. So iron tu tak boleh jadi jawapan dia. The product can never be the one undergoing oxidation or reduction. So this one here will be sama ada you spell it out. Nak selamat, you spell it out. Because, kenapa kita nak spell it out? Because the answer is here. Iron 3 oxide. So, you takkan silap lah. Okay. Ataupun Fe2O3. Ataupun, okay, they still accept Fe3+. Tapi ini jaranglah orang buat. Okay. Boleh? Okay, so we go, sebabkan until there, it is 1.1. Okay, we go further into the other questions untuk cari 1.1. Okay, kejap. Before we go into this essay question, kita tengok dulu 1.1. Okay, this one I wanted to emphasize on this one. SPM 2015. Boleh ke flip your paper? Okay, the question starts with double decomposition is not a redox reaction. So by using suitable example, explain why double decomposition reaction is not a redox reaction in terms of oxidation number. Okay, so kita kena give an example, meaning kita bagi a chemical equation lah. Okay, boleh ke? Okay, cuma yeah. Okay, so katalah my example is silver nitrate reacting with, let's say, sodium chloride, producing silver chloride and sodium nitrate. Okay. One thing, when you want to explain based on the oxidation number, alamak, this color is not so terang Okay. When you explain based on the oxidation number, it has to be the oxidation number of each element. Kan ikut charge. Okay, what I mean is, okay, this will be your first answer. Then the second answer, you will write the oxidation number before reaction. Okay, so you have Ag, N, O, lepas tu Na, and also Cl. You kena pecahkan this NO3 ni into N and also O. Kita tak boleh ambil as NO3 minus sebab oxidation number is for element. That was the justification given lah. Okay, so Ag kat sini, the oxidation number is? What is the oxidation number of Ag in this case? Ni. Yeah? Anyone?
1.
Positive 1, yeah. Okay. Oxidation number of nitrogen? That one, you have to calculate. Okay, kita tengok sikit how to calculate it. Okay, AgNO3, this whole thing, oxidation number dia is 0. Okay, because compounds, oxidation number is 0. Okay, so katalah we don't know the nitrogen. Okay, the rest we know. So Ag is positive 1, ikut charge dia. Plus X plus 3 times negative 2. Oxidation number of oxygen is always negative 2 except for in peroxides. Okay, so you will always jumpa oxygen being oxidation number negative 2 lah. So plus 1 plus X minus 6 equals 0. So minus 5 plus X equals 0. So X is positive 5. Therefore, oxidation number of nitrogen in this case is positive 5. So kat sini, you will be writing it positive 5. This part, yang ini you scribble lah somewhere in the test pad tu. Bukannya in your answer. Not necessary to show how you got to positive 5. Okay. Lepas tu, for oxygen, it's negative 2. For sodium, it's sodium?
1.
Positive 1. Mesti ada simbol tau. Mesti ada simbol, mesti ada the number. Okay, and for chloride, for chlorine?
Negative 1.
Negative 1. Okay, that is the oxidation number before the reaction. So then the next point that you're going to write is oxidation number after the reaction. Okay, what you can also do adalah do a table where dekat sebelah tu you tulis for before the reaction, then sebelah lagi is the after reaction lah. Okay. So number 3, oxidation number after reaction. Okay, so back to Ag, NO, NaCl. So everything is the same. Positive 1, positive 5, negative 2, positive 1, negative 1. Okay, then your conclusion is you're going to write no change in oxidation number. For all elements. So each one of these will carry 1 mark. So this example will carry the first mark. This whole thing will carry the second mark. And this one will be the third mark. Final one, the final conclusion where you say there's no change in oxidation number, then this one is the 4th mark. Okay. And if you browse through, kalau you selak the paper, ada soalan ke untuk that? I think it is clear code. Betul ke?
Clear.
Okay. So kalau tengok in SPM 2017, there is the similar question. Cuma yang ini they ask you to identify which one is redox and which one is not. Apa ke?
Okay, so you can do the same method. So I won't be showing it here. Nanti the marks, the suggested answer for the whole handout, I'll be giving to Cikgu Rizah lah. Okay, so you can try doing this. It's the same method of doing it. Okay. Okay. Okay, so I think, okay. Now, since we are at 2017, kita tengok sedikit this displacement reaction ni sebenarnya. Okay, diagram 8 shows the information for reaction 1 and reaction 2, setup of the apparatus. Ada metal M, and then there is copper to sulfate solution. Okay. Then the observation for that is blue solution turns colorless. Okay, kita tahu blue means it involves iron 2 ion. One thing about chemistry is it is colorful, as in there are so many colors to remember. Okay, tapi kalau you perasan, it's again and again the same thing. Kalau blue, it is always the copper 2 ion. Okay, kalau green, it is always the iron 2 ion. Kalau brown, it is always the iron 3 ion. Okay, macam tu. So it's a typical one lah. Dia takkan jadi out of the blue, out of the ordinary punya soalan. Okay. Reaction 2, you have silver nitrate solution. Okay, with metal N. And then the colorless solution turns blue again. So that means here kita ada which ion?
Hello?
Yeah. Which ion? Yang blue. Anyone?
Copper ion.
Yes, copper 2 ion again. Okay. So kalau kita tahu copper 2 ion, then dia macam ada hint lah there. Okay. So based on the information in diagram 8, suggest the suitable metals for M and N. Okay. So from a blue solution to turn to colorless, that means this, for this first reaction, kita scribble dulu. This copper 2 ion, it will turn to become copper. Okay, for that to happen, this metal M must be a metal that is more electropositive than copper. Okay. Metal M has to be a metal that is more electropositive than copper. Okay, how to know this? For your syllabus, we have this standard electrode potential series kan? At the beginning of this handout, I've put in. Okay. We have the standard electrode potential series. Okay, from there you can determine whether that metal is more electropositive or less electropositive. Okay, one thing is do not memorize this list. It will be given in the question, the specific question. It won't be given, dia takkan give you in this whole list tau. It's not like the periodic table, no. It will be given in the specific question. Maksudnya, because tadi tu is a KBSM question, so dia tak ada lah this standard electrode potential series ni. But in your case, let's say the same question comes up again. They will be giving you the standard electrode potential tu lah. Okay. So what you can do is, kalau nak tengok that the metal is more electropositive than copper tu tadi, that metal will have an E0 value that is more negative. Okay, copper kat sini. Apa tu? Copper 2 ion tu ni kat sini kan. Okay. So it has to be any metal that is above it. Yang nilai dia more negative than this positive 0.34. Boleh ke? Did I make you, is it confusing? So, kalau tengok kat situ, going back to that, that? 2017. Okay. So this metal M is normally kita akan kata metal M ni is either magnesium or zinc or aluminium lah. These are the typical ones that we normally see. Okay. Okay. So in this case, for point number 1 in your answer to suggest metal M, dia tak cakap dia nak nama, dia tak cakap dia nak formula. So you can write either one. You can either spell out, katalah you want to choose magnesium as the answer. You can either spell it out ataupun you can give the formula. Okay. In the case of N ni kita dah tahu that N is actually copper. Kenapa it is copper? Sebab kalau kita tengok closely, sebab it produces copper to ion. So if it produces copper to ion, it has to be copper reacting with silver nitrate. Copper reacting with silver nitrate, what will happen is copper is more electropositive than silver. So copper has this power over silver to go and tendang dia keluar. That's why it is called displacement. Displace, sesarkan. In physics you learn displacement juga kan. So dia sesarkan. So this will become copper to nitrate and silver. Okay, so kalau kita balance that like that. Okay. So kita, because dia dah sebut dah it turns blue, so we know that ada copper to ion. So kalau ada copper to ion, ada copper lah kat sini. So the only answer for N is copper. Tak boleh jadi benda lain. Kalau M tadi, it can be zinc, it can be aluminium also, or anything else that is above copper lah in that series. Okay, one thing I want to remind you adalah the spelling of copper is C-O-P-P-E-R, not C-U. Okay. Okay, then the next one will be to write the ionic equation. Yang ini saya rasa Cikgu Nuriza mesti ada bagi dia punya how to remember. Okay, ionic equation. Ionic equation means mesti ada something that has charge. Yang what I have written here is a chemical equation. Okay, so in this case, macam saya, I need to write the chemical equation first, then only I can write the ionic equation. So you are free to do however lah kan. Okay, so let's say my metal M tu tadi is magnesium. So it will be magnesium plus copper to sulfate, producing magnesium sulfate and also copper. Okay. So yang ini, to do the ionic equation, ada certain things kita kena cerai, ada certain things remains the same. So this one remains because it is an atom. This is a soluble salt, so you can ceraikan dia into its ion. So it will be Cu2 plus and also SO4 2 negative. Okay. For this magnesium sulfate, it is also a soluble salt, so you can ceraikan dia. So it becomes Mg2 plus and also sulfate. Okay. Copper stays as copper. Dia tak tiba-tiba jadi ion-nya. Ini what my students normally do. The atoms will remain as itself. Atom, molecule and also insoluble salt. You cannot ceraikan and it will remain as itself. Kalau in the chemical equation it is an atom, so it remains as atom lah in the ionic equation. So then you cancel off ions or anything that is sebelah, before the arrow dia ada, sebelah lepas arrow pun dia ada. So in this case, sulfate sahaja. Okay, so then your ionic equation for the first reaction will be Mg plus Cu2 plus, arrow, Mg2 plus, and also Cu. This is for the first reaction. For the second reaction, since I have written this chemical equation ni. Okay, so this one will stay as itself because this is an atom. Okay, then this one will be ada dua kat depan ni. Bear in mind that is the dua in front there, so it will be 2Ag plus. And then the 2 also belongs to the nitrate, so plus 2 nitrate. Those are before the arrow. Then after the arrow, we have this Cu here is the ion, so Cu2 plus 2 of the nitrate. So 2 nitrate ion plus 2 Ag. Okay, agak bersepah sikit. Ni nanti saya susun supaya it's clear. Okay, so then you cancel off whatever that is on the left that is also exactly the same. Segi bond sama tu, then only you cancel off. Okay, so 2 nitrate, 2 nitrate. So your ionic equation for the second reaction will be like that. Okay, so katalah I put them together, kejap ya. Okay, so ada berapa markah? Okay, here magnesium ni 1, copper ni 2. Okay, the second mark. Okay, each ionic equation will get you 2 marks. One for the formulae of reactants and product. Then the second part of the mark is the balancing lah. So in this case, this will be point number 3, markah nombor 3, and then mark number 4. So this is mark number 5, this is mark number 6. So total 6 marks. Simple aja soalan dia, simple aja benda yang you have to write. Okay ke everyone? Okay. Alright. Okay, so then kita pergi kepada this is another one. Okay, this is another one. Before we go into this one, kita tengok dulu. There is one that my friend gave. My previous roommate masa okay, yang ni. Kalau perasan dia macam togel aja, tak ada apa saya lukis. Okay, there is a way to remember this for oxidizing agent and also reducing agent. Okay, kita nak remember reducing agent and also oxidizing agent. Okay, so what we will do is we will start sebab ini dah cantik sangat kan, I will draw it here. Okay, we will start the drawing with writing reducing agent on the left hand side and oxidizing agent on the right hand side. Okay, the way to remember is for you baby, I climb mountains, cross bridges. Boleh. For you baby, I climb mountains, cross bridges. Okay, so those on the left hand side are your reducing agent. What are they? Okay, this is iron 2, bromide, and iodine. On the right hand side are your macam mana kena hilangkan ini? Okay. On the right hand side are your oxidizing agents, so chlorine, manganate 7, dichromate 6. Okay, and also bromine water. Tu cara nak ingat dia. So it applies to YouTube and also YouTube as in the tube U ni, and also the test tube punya style. Tahu tak yang mana? Which one I'm referring to?
Teacher,
Yeah?
can you write the mnemonic system again?
Oh, okay. 4. Then U is the referring to the YouTube. Saya tulis kat sini lah. For you, baby. I, saya jarakkan. Climb mountains. Cross bridges. Okay. For you, the YouTube. Baby is for the bromide. I is for the iodide. Climb is for chlorine. Mountains is for manganate 7. acidified manganate 7 solution. Cross is for dichromate 6. And bridges is for bromine. Okay, boleh kan? That's how to remember lah. That's one way of remembering it. So, why did I show you this? Is because kita akan guna sat lagi dekat that question just now. Okay, so it is also applied here. So nanti you can rewrite here. Saya tak conteng kat sini, you can write yours lah. Yang ini I took from the textbook. That's why there is the green color and the purple color. Green ni because it's originally they have written it for iron 2 sulfate. And this one is for potassium manganate 7, acidified potassium manganate 7 solution. So that's why it's green and purple. One thing I want you to know is it's not necessary, tak semestinya the reducing agent mesti on the left hand side and the oxidizing agent must be on the right hand side. Tak Cuma kita nak bagi senang ingat, so that's why we have put reducing agent on the left hand side, oxidizing agent on the right hand side. That's why nanti even the galvanometer needle pun will turn to this way lah. Betul tak? You've seen a galvanometer. You nanti once you go back to school, try this one out. Dia memang you can see that the galvanometer needle will deflect from where the from where the reducing agent is to the oxidizing agent. Cuma it will take time lah untuk the change in color tu. Okay, so going back to the question tadi. Okay, sebab saya nak guna that just now. Dekat mana ya? See this one? No. Ni. Okay. So using that tadi, nanti kita akan apply kat sini. By using solution P and solution Q, Fe2 plus ion can be converted to Fe3 plus ion and vice versa. Okay. So if we have iron 2 just now tadi, iron 2 is what agent? Iron 2 is?
Reducing.
Yeah, reducing agent. So then solution P mesti partner dia mesti
Oxidizing agent.
Oxidizing agent. Okay. Lepas tu kita bolehlah pilih from that climb mountains, cross bridges tu, from that list. Okay. So then this one pula, kalau Fe2 is a reducing agent, this is Fe3 oxidizing agent. Okay, walaupun dia tak ada dalam list yang mnemonics tadi, tapi we can tell lah kan. Sebab iron 2 will only turn into iron 3, iron 3 will only turn into iron 2. Dia that way ni. Okay, so if this one is already an oxidizing agent, that means solution Q mesti?
Reducing agent.
So then you can choose from that list lah. Okay. So based on reaction 1 and reaction 2, suggest suitable substances for solution P and solution Q. So let's say you nak pilih for P, apa you nak pilih?
Bromine water.
Nak senang kita ambil bromine water. So you can write bromine ataupun Br2. You tak ada perkataan water pun tak apa. Okay, bromine ataupun bromine water tu pun. Hilang dah. Okay. Okay, then it says here dia nak kita identify untuk Q. Okay, so Q?
Potassium iodide.
Ya, boleh? Potassium iodide. Ini satu benda. Potassium is spelled with double S and not double T. Be careful kebanyakan orang will write it this way. This is super wrong. Salah. Sebab when you spell it out, everything must be correct for scientific term. Potassium iodide. If you tak suka potassium iodide, you can choose potassium bromide juga. Tapi janganlah pula choose iron tu. It has to be something else other than iron lah sebaik. Okay. Potassium iodide or Ki. P ni not necessary bromine sahaja. You can put chlorine. You can put acidified potassium manganate 7 solution. Acidified potassium dichromate 6 solution. Boleh. Okay. So banyak option jawapan. In the suggested answer, kejap ya, I show you. In the suggested answer, saya dah letak the slashes. Mana dia? Eh. 2017. Ni. Okay, dah. Saya dah letak the slashes. So nanti you can refer to this when you study again lah. Okay. So kat sini we discuss bromine dengan potassium iodide je lah. Okay. So then dia kata then choosing either reaction 1 or reaction 2. Describe one experiment to study the transfer of electron at a distance. So it's basically the YouTube tu lah. Okay. In your description, include a label diagram. Okay, what they have asked you is to include the label diagram and also the ionic equation. Okay, so let's see, kita start dengan drawing of this. Okay. Apa yang orang selalu lupa to write to draw? Okay, this point number 3 will be functional diagram. Functional diagram ada a few criteria to get you that 1 mark. Okay, it comes together with the label. Okay, so we have the YouTube. Okay, kita jenis manusia yang lupa kan? The immediate thing that you do is draw the retort stand. Sebabnya nanti kalau kita tak draw siap-siap, we will forget. So that be the first thing that you draw lah, the YouTube and then the retort stand. And then you have the carbon electrodes. Okay, and then it is connected to a galvanometer. Okay, and each one of these kita akan masukkan into solution. Okay. Okay. So that electrode mesti completely masuk dekat dalam, maksud saya adalah macam ni. So ada dashes in the solution. Okay, and then here dekat dalam ni will be sulfuric acid. Okay, so what to label? What to label is the sulfuric acid, dilute sulfuric acid. Tak ada perkataan dilute is fine, tapi mesti ada sulfuric acid. Either you spell it out atau you tulis the chemical formula. Okay, lepas tu this one tengoklah whatever that you have chosen for P tadi, bromine, water. Tulislah. Normally kita akan tulislah bromine, water. Okay, and then here will be sorry. Okay. Sorry. Katalah you choose the first reaction, sorry. This will be iron 2 sulfate. This will be bromine, water. Okay. Boleh ke? Dekat sini I have put in what are the things that you have to have for functional diagram. You must have dash line for solution. Solution kat sini will refer to this one kena ada dash line. This one inside here mesti ada dash line. This one mesti ada dash line. Okay, itu satu. And then electrodes put into oxidizing agent and reducing agent respectively but does not touch the sulfuric acid. Okay, so ni kita dah immerse the electrode into the solution lah. Oxidation and the, oxidizing and the reducing agent. And then you have the galvanometer and the wire does not touch the solution. Okay, and the U-tube is clamped. Okay, then the labeling here will be, ikutlah your P tadi, iron 2 sulfate solution. This one is bromine water. Gitu. If you are doing the first reaction. So kalau is the second reaction and then you tukar lah. Okay. Boleh ke? Then what that is the fourth mark already. Then you nak buat the procedure of the experiment. So pour dilute sulfuric acid into U-tube. Okay. Lepas tu add 1 mole per decimeter cube potassium chloride. Kalau just now guna potassium chloride dan potassium chloride lah. Kalau you nak, in this case, you nak guna iron 2 sulfate solution. Slowly, the word slowly mesti ada. Into the right arm to a height of 3 cm. Okay, to a height of 3 cm ni dalam SPM not necessary. Okay, dalam SPM not necessary. Tapi the word slowly mesti ada. And then kita add 1 mole per decimeter cube potassium chloride solution slowly into the right arm. Sorry, this one into the left arm. The other one is into the right arm. Okay, nanti saya betulkan the suggested answer. Okay, then dip the carbon electrodes into both arms of the U-tube and connect. Okay, to get point number 8, you have to have both things. Okay, so dip carbon electrodes into both arms of the U-tube and connect to the galvanometer. And then leave the apparatus for 20 minutes. 20 minutes ke 30 minutes ke 1 hour ke boleh lah. Tak apa tu. Okay, and record the changes. And then you write the ionic equation sebab they have asked you to write the ionic equation. Up till now, okay ke everyone?
Tu kena tulis ke?
Apa yang kena tulis?
Height.
Height tu kalau tak tulis dalam SPM is okay.
Oh.
Sebabnya saya tulis kenapa? Sebab nanti you will ask me tak perlu tulis volume ke? Dalam case soalan ini they don't require you to write the volume. The height tu macam just to tell you apa ni nak jadikan jawapan kita an A+ student macam tu lah. That's how an A+ student writes lah. To a height of 3 cm ke apa benda. And even in your textbook pun ada. Tetapi dalam SPM actual marking dia tak payah pun tulis this. Yang saya kurungkan ni is not required. Okay ke?
Yang sulfuric acid itu memang must be sulfuric acid ke ataupun any other acid? Can be.
Biasanya we put in sulfuric acid. You want to change, you can change to potassium nitrate, potassium chloride, sodium nitrate solution, boleh. Tetapi memang biasanya we put in sulfuric acid even as we do it in the laboratory, school lab. Okay. Okay kah? Everyone? My other laptop ni has gone off, so saya tak tahu if you are asking me questions dekat situ.
Oh, cikgu.
Yes, saya.
Boleh ulang balik tak? Selain daripada apa? Sulfuric acid tu boleh letak apa?
Okay. Boleh letak potassium nitrate solution, potassium chloride solution, sodium nitrate. solution. The same exact thing that you can replace untuk salt bridge is the same thing. Kan salt bridge tahu kan yang ni, yang duduk dah ni. These are the things, these are the solution that you can put into salt bridge. Also dekat dalam nak ganti sulfuric acid, the same things because they have the same function to allow the movement of ions. Okay. Tapi potassium nitrate, potassium chloride semua ni kena ada perkataan solution lah ya, because otherwise it is in solid form. Okay, boleh?
Boleh.
Okay.
Boleh.
So we go to the next one. Where is it? Yang ini is also about displacement. Okay, displacement reaction. Okay, so when this question came up, dia tak ada lagi about the E naught and everything. So dia punya explanation is all about being more electropositive or apalah the metal, which one is more electropositive, which one is less. So in this question, they have asked you to that zinc can displace copper from copper to sulfate solution. That concept just now yang tendang keluar tu. Give one reason for the above statement and write the chemical equation involved. Okay, so I have included the answer based on your syllabus. So previously the answer will be zinc is more electropositive than copper. So now because your syllabus has got electrode potential value tu, E naught tu, so what you can write is, if you don't want to write that, the E naught value of zinc is more negative than E naught value of copper. What I have been told is like this kind of question, they will give you the half equation tu. Contohnya Zn, kita tengok the series tu. They will give you the specific one. Ni. Contoh in that question just now, they will give you this one, this particular one, and copper. Ni. They will put it there. And then they will ask you to explain lah. Sorry ya, going back and forth ni kalau membandingkan. Okay, so that's why the answer there, you can tell sama ada you say that zinc is more electropositive than copper, or you can say that the E naught value of zinc is more negative than the E naught value of copper. That is why zinc can displace copper from copper to sulfate solution. And after that, write the chemical equation. Boleh ke?
Intan, nak mencelah.
Oh ya.
Kalau student katalah dia tak mahir lagi penggunaan E note tu kan, sebab dia still confused lagi, but before this masa form 4 kita masih memperkenalkan more electropositive, more electronegative. Adakah accepted, diterima dalam
Boleh?
scheme?
Setakat yang Cikgu Zulkifli Mahmud bagi tahu boleh.
Boleh takut sebab
boleh.
certain of them sebab kita masa form 4 tak diperkenalkan lagi kan, tapi bila masuk form 5 jadi budak jadi confused certain of them.
Okay. And if you look at buku teks also, they still explain based on electropositivity. Cuma after that, they have an explanation about the E naught. Kita tengok sikit lah buku teks. Buku teks memang mention that part of it. Where is it? Penyesaran. Displacement reaction of ni. Okay. Nampak tak dia punya explanation macam mana? They explain more electropositive metals, blah blah blah. So that's why Cikgu Zul kata memang boleh explain based on electropositivity.
Alright.
Okay, cuma kalau it is given the E naught, sebenarnya if you dah ada E naught tu lagi senang nak explain, tapi tengoklah because kita tak biasa kan. Itulah. Cikgu-cikgu pun tak biasa. Saya rasa semua orang is new for us. Yang macam we have left chemistry degree days dah lama sangat-sangat. So we are actually studying juga. Okay. Now saya rasa the 1.1, the rest of it you can try and do it yourself. Kita go into electrolysis. Sebab if you realize, if you flip through, the paper banyak questions related to electrolysis. Okay, and electrolysis became difficult because of the E0 thing. Okay, sebenarnya yang apa ni, electrolysis tak susah langsung. Okay, so sama juga konsep dia. I have put in this one sebab this was the one that I used for didik TV tu, so saya put in sahaja. Okay, untuk answer electrolysis question, we have 3 factors. Okay, this is involving aqueous electrolyte lah ya. Kenapa I mention about aqueous electrolyte? Sebab most questions when it involves electrolysis, they use aqueous solution. Seldom if you flip through, dia ada 1 or 2 years sahaja yang ada about molten. Why? Because molten punya soalan sangat senang untuk jawab lah. Bila dia aqueous solution, the thinking is more. Okay, kenapa nanti we go through lah ya. So kalau saya, I will teach my students to first, you label your anode and cathode based on your battery. Based on the battery. Okay, and then you look at the electrolyte, you list down the positive ions and the negative ions. Okay, so the negative ion will go to anode. The name tu sama kan, so anion goes to anode. Negative ion, that is the N there, will go to, sorry, negative here, ada N there, will go to anode. Okay, then the positive ion, that is the positive sign, looks like a T, so it will go to cathode. Okay, so now kita focus on the anion at the anode. Apa anion buat? Dekat situ you will have to compare the E0 values of the anion. Okay, E0 value of anion which is more negative, that one will be chosen. Nanti kita tengok the sample question lah. Okay, from there you write the half equation and the observation and the inference, and the type of reaction that occurs is oxidation. Okay, at the anode is oxidation. Okay, for the cathode, okay, the one that went to the cathode is the cation. The cation with a less negative E0 value or more positive E0 value will be chosen to discharge. And then you write the half equation, the observation, inference, and the type of reaction will be reduction. So I believe you all ada guna this one. N-ox red cat. N-ox is anode, is oxidation. Reduction is where? Is at the cathode. And ox red cat. Okay, that one is based on E0 value. Yang senarai itu tadi. Okay, the second factor is about when the electrolyte is concentrated. Tetapi the thing that you have to pay attention is this thing only involves halide solution. Maksudnya, if they say lah, let's say they say the electrolyte is 1.0 mole per decimeter cube. This is considered concentrated untuk an electrolyte. So if they say it is 1 mole per decimeter cube, that solution is concentrated lah. Okay, then you look at what solution it is. Only when it has halide, you pay attention. Otherwise, you patah balik dekat E0 punya factor. So katalah it's hydrochloric acid, or it's sodium chloride, or it's sodium iodide, or whatever that has the halide tu, baru you pay attention, baru you ubah this one, this part will change. Kalau it is concentrated tapi let's say it is just copper to sulfate, there's no halide at all, it is back to this one. The way to choose ke apa benda tu, it follows this one, E0 value. Okay. So what happens is, whatever the change is, it only happens at the anode. Cathode ni sangat mendengar kata, as in, dia follow je. Tak kisahlah whatever factor that changes, cathode ni dia takkan berubah in the way of choosing the ion. It is still the cation with the E naught value that is less negative or more positive. Tak kisahlah the solution tu pekat ke cair ke, it is still that way. So the one that changes is only happening at the anode sahaja. So in the case that the electrolyte is a concentrated solution, then you will choose the halide even though halide tu contohnya, katalah we have iodide dengan hydroxide kan. Okay, remember tadi kalau based on E naught, kita kata at the anode, we have the anion. So anion Ni anion, okay. So we will choose the more negative kan atau less positive kan. Supposedly kita choose hydroxide kan. Tetapi because ada halide, then tak kisah ada hydroxide, we will choose the halide. Macam tu maksud dia. Clear kah? Pening ke?
Okay.
Okay. Then the other factor is type of electrode. Okay. Again, this thing only affects the anode. No changes at the cathode. Okay. So the cat anode tu, we have, let's say we have hydroxide, we have sulfate, let's say. Okay. Supposedly kalau we follow the E naught value, we will be choosing hydroxide. Sebab hydroxide will have a less negative, a more negative E naught value. Tetapi when they use an inert electrode, none of the ions will donate electron. It is the anode, the electrode tu sendiri yang will donate electron. Then everything will follow suit. And if you realize, kalau you freak through, selalunya the question involves this one. Nanti kita tengok. Okay, let's see. Kita look at this first one. First one is the typical one. Okay, so this is an SPM 2013 question. So when it is made your question, Kssm, I was told that they will be giving you lah the E naught value tu semua dia senaraikan kat sini. Corresponding to the question. Itu sahaja. Kalau ada 4 that they need to give, they will give 4 only. They won't give the whole list. Tak. Okay. So in this case, sebab I don't want to change the SPM question, so I didn't insert anything lah. So nanti kita refer back to the E naught values. So diagram 4 shows the apparatus set up for the electrolysis of sodium nitrate solution. Okay. When you look at this, you write lah siap-siap dia punya formula of the solution. Okay, remember that it is solution. Okay. So now kat sini, they have asked you to write the formula of all ions present in sodium nitrate solution. Anybody wants to try this one out?
H plus.
H plus? Sahaja ke?
Na.
Na je. Na? Plus. Okay, lagi?
OH negatif.
OH
It's
negative.
minus. SO4 to minus. Silap. NO3.
Okay. NO3 negative. Like that. Kenapa ada H plus and OH negative? Because it is solution. That means to make the solution, you actually have sodium nitrate tu dalam pepejal. Then you add in water. That's how they become solution. So that's why kita kena give credit lah to the water. So H plus and OH minus comes from the water. So this will get you the first mark. Okay, sorry. The 1 mark lah. Ni bukan essay. Okay. Now, electrode Q acts as the cathode. Okay, so before we go into that, kita tengok dulu ya. Kita label. This is the positive terminal of the battery. This is the negative terminal of the battery. So, positive terminal ni akan connect to what electrode is this?
Anode.
Anode, yeah. So this one is the cathode.
Cathode.
Yeah. Okay. So siapa go to the anode just now?
Anion.
Anion. So you have the nitrate and also hydroxide. Okay, and at the cathode you'll be hydrogen ion and also sodium ion. So dekat sini lah the E naught values plays a role lah. Okay. Before we go into that, question B says electrode QX as cathode. What is the meaning of cathode? Apa maksud cathode?
Cathode negative terminal.
Negative terminal je you're going to answer.
Electrode that
Electrode connect
Electrode
with
that. Betul. Lagi.
negative terminal.
Electrode that is connected to the negative terminal of?
battery.
Yeah.
Battery.
Yeah. So electrode that is connected to the negative. Betul. Negative terminal of the battery. Oh ya. Yang ada tulisan berangkai. Cursive handwriting. Learn to write seketul-seketul. Nanti kadang-kadang people don't understand your handwriting. Okay?
Intan, kalau tulisan kecil sangat kecil sampai kena pakai kanta pembesar, what should I do?
Besarkanlah tulisan you. You know that handwriting, you can tell a character based on the handwriting. If you write too small, that means you are a timid person. So, jangan be timid. Be confident. So, enlarge your tulisan. Nanti bila nak di-scan lagi, is lagi worse. Scanner machine tu. You can imagine there are hundreds of thousands of you tahu yang answer chemistry paper. So mudahkan. What I normally tell my students is you mudahkan the pemeriksa to give you the mark for your benefit. So whatever that you can do to gain marks lah kiranya. So improve on your handwriting. Okay, what is guess why? So in this case, okay, we have hydrogen ion and sodium ion ni kat sini. So what we do is we look into the E naught value. So kita sebab you will have to learn how to use this thing. So kita tengok dekat E naught value, cari the hydrogen ion. Hydrogen ion is 0.00 lah. Okay, and also the sodium ion. Where is sodium ion? Ni. Okay. This one is cat ion kan? Betul tak? Ni cat ion kan?
Betul.
Okay.
Yes.
So if cat ion, we choose E naught value yang macam mana?
Positif.
Yang more positive ataupun less negative kan? So in this case, kita akan choose the hydrogen ion lah. Okay. So because of that, kita tahu the product will be hydrogen gas. So kita pun tulislah hydrogen gas. What is gas Y? Hydrogen gas. Okay. Explain your answer. Why have you chosen why have you chosen H plus tadi? So E naught value of H plus is less negative. Less negative than E naught value of Na positive. So H plus is selectively discharged or it is reduced. Okay. Then they say gas X is collected at the anode. Gas X can rekindle glowing splinter. Kita dah tahu dah the gas kan? What is the gas?
Oxygen.
Yeah, oxygen gas.
Yes.
Okay, so write the half equation. This one would probably macam, I don't know how it's going to be done in your exam paper. Nobody knows actually. Only the panel who sets the question knows at this point. So kita pun tak tahu how exactly, but they say, from the rumors I heard, they say they can still ask you the half equation. Kenapa they can ask you the half equation? If you look properly, sebab the equation kat sini, okay, kalau kita tengok, ini kan, kita nak ambil yang ini kan? Betul tak? We will be taking this question, this equation, tetapi we cannot follow terus ambil macam ni. This hydroxide has to be the reactant, this part yang jadi the product. So kita kena terbalikkan the equation. So they say it is still possible to ask you the half equation. How exactly they are going to put in the question paper tu, kita don't know. Actually, you will be the first one to know how it is put inside the question paper. Sebab teachers cannot go inside the exam hall in SPM. Okay, so 4OH minus becomes 2H2O plus O2 plus 4 electrons. Macam tu. So when asked, do we have to memorize? Dulu KBSM students, they have to memorize this half equation. So when asked whether you have to memorize, some cikgu-cikgu yang otai akan kata, they say no need to memorize anymore the half equation. It's just that you have to know which one you want to put as the reactant, which one you want to put as the product. Sebab dia dah kata dah, this oxygen is collected at the anode, that means oxygen is a product. So you just switch sahaja kedudukan the reactant and the product. Okay. Ke? Okay ke everyone? Bila senyap ni rasa macam tak ada orang.
Adik.
Okay. So then the next question, D, we proceed. D, Rosli discovers his key which is made of iron, has rusted. Iron is rusted. Okay, so by using the knowledge of electrolysis, describe briefly how he solves the problem. So you nak guna what sort of method here?
Electroplating.
Yeah, you nak guna electroplating. In electroplating, the thing that you must remember adalah who you want to place the anode, who you want to place at the cathode, and what is your electrolyte. So macam yang saya mention dekat dalam didik TV tu, saya guna tu. Sebab saya guna bahasa Melayu. So penyadur at anode, cathode is the object. Okay, so what you can write here is put iron key as the cathode. Okay, and you want to electroplate this with what?
Iron.
Okay, tengok the problem is iron ni, the problem is the key ni, that is the object which is made of iron. Dia dah rust. So you nak sado dia dengan something that can rust again?
No.
Okay. So what you want to use? What do you want to use? Silver. Okay. Wah, kaya orang ni. Okay, boleh. You can either use silver. Boleh tau. Saya melawak je tu tau. Nanti kalau you ingat tak boleh guna pula. Silver or copper. Okay, this is the typical ones lah that we normally use untuk this question of electroplating. Silver or copper as the anode. And the solution, the electrolyte must follow siapa?
Must have the anode. Silver, contoh silver nitrate.
Mesti ada silver ion, yes, betul? Okay. So in this case, you nak guna, kalau you nak guna silver tu tadi, then silver nitrate solution as electrolyte. Macam ni je jawapan dia sebenarnya. In the actual SPM. Every time electroplating comes out. Okay. So dia tak susah sebenarnya. InsyaAllah. Okay, we go into another question. This is yeah,
Cikgu, selain silver nitrate boleh pakai apa je?
silver sulfate.
Silver sulfate.
Yeah. Kalau
Maknanya
copper,
boleh letak garam apa-apa lah.
dia
Macam
cannot.
mana?
It has to be a soluble salt.
Soluble salt. Oh, betul.
So macam so silver tak boleh guna silver chloride lah. Silver chloride is an insoluble salt, so it cannot function as an electrolyte, so you cannot put that as the electrolyte. In the case of copper, copper lagi banyak option lah. So if you use copper as the anode, then you will have copper to nitrate. You can have copper to nitrate as the electrolyte, copper to chloride, copper to sulfate, boleh. Asalkan you don't put copper to carbonate sahaja.
Oh.
Okay, boleh. Okay, so we proceed to the next. Dekat sini baru ada, inilah tahun 2014 and another year kot, I think, ada Molten. So, kita tengok dulu. Diagram 4.1 and 4.2 shows the apparatus set up for two electrolytic cell with different electrolytes. Okay. The first question is state the meaning of electrolyte. Okay, so one thing I want to remind you, akan ada banyak benda yang kena ada meaning-meaning ni. Sebab now, because it is a Kssm question, the first question will normally be aras construct pengetahuan. Okay, it means nothing to you, but construct pengetahuan ni mostly is definition, benda-benda macam definition tu lah, giving istilah. Maksud they give you something, some ayat. What is that referring to? So you give the istilah. So it's basically memuntahkan benda lah. So all question in the SPM paper for KSSM, it starts with those kind of questions. Pengetahuan. Construct pengetahuan. Okay. So banyaklah akan ada soalan yang maksud-maksud ni. Okay. So apa maksud electrolyte? Apa maksud electrolyte? Anyone?
Things that can conduct electricity in either molten or aqueous solution.
Okay.
And undergo chemical changes.
Ya betul. Substance lah, bukan things. Substance that conducts
Electricity.
Electricity
Molten or aqueous
in
solution.
yang ini kena be careful. Ejaan untuk aqueous, in molten or aqueous. Dia banyak vowels. In molten or aqueous solution and undergoes chemical change.
Cikgu nak tanya, kalau
Ya.
untuk salah ejaan kan, contohlah tertinggal satu huruf kan, salah ke? Macam aqueous tu kan, salah lah.
Sebab kan
ada lebih bicara.
sebab dia adalah satu istilah sains, maka dia jadi salah. Tapi you doa banyak-banyak that the pemeriksa did not see your salah tu. Sebab macam mana pun Allah yang bagi kan. So doalah banyak-banyak, orang tak nampak. And jawab, dia nak bagi markah je kat you. You doa macam tu. Jangan doa for soalan senang. Doa for whatever question that comes out, you can answer. Be it senang or susah. Sometimes the soalan senang is the one that people do careless mistakes. Okay, so kalau boleh jangan adalah sebenarnya salah dia akan pangkah jika you ada salah eja pada istilah sains. Contoh undergo ni tak ada ES ni tak apa. Tapi bila aqueous ni kena be careful lah. That's why one of the most difficult thing to spell out is phenolphthalein.
Phenolphthalein.
Phenol dia ada banyak H.
Intan nak mencelah, nak tanya, kalau macam ada certain tu kan, ada certain daripada kita tengok skema, dia tulis hydrogen ions dengan ada setengah dulu pemeriksa, dia kata kalau tak ada S, hydrogen ions, dengan hydrogen ion tu, tak ada S je, dia terus salahkan jawapan tu. Adakah masih lagi ke tidak?
Tak. Plural and ni singular tak. Tak.
Sebab hari tu ada tanya, dia kata ya. Tu yang rasa alamak takkan sebab tak ada S kot.
Tak, kita
Tu
bukan
nak confirm ni
English.
sekali lagi.
Itu sebab macam mana pun dia doa lah supaya dapat pemeriksa yang tak terlalu strict, yang macam in that case itu personal opinion kot. Setakat ini ada S ke tak ada S ke diterima. Even there was an argument, even diorang di kalangan orang yang besar-besar tu writing this, it means an ion already kan. Some people say you have to have the word ion. Kalau saya, this one is already correct because you have the plus sign. It shows that it is redundant to have the word ion. Tapi ada setengah orang, dia kata kena ada perkataan ion. So they fought for it. So now this is accepted. Even if without the word ion is fine. It means an ion already with the charge. That's why kalau spell itu yang kena be careful. Bila you spell out, kalau you tulis ini sahaja, it becomes wrong. In this case, you kena adalah perkataan ion. Tapi kalau it is a formula, this one is correct. Betul je. Macam tu. Okay ke tak? Okay. Okay, so based on diagram 4.1, why does the bulb light up when molten lead to bromide is used as electrolyte? 4.1 sahaja. Kita fokus kat 4.1 sahaja. Ni. So why does the light the bulb lights up?
Of free moving ion.
Yeah. The ions are free to move. There are free moving ions. As long as you have the word ions and they are free to move. There are free moving ions. Kenapa? Okay. If this question were a 2-mark question, kalau like instead of 1 mark, dia kata 2 marks, then the next ayat will be to carry electrical charges. This came out in 1 year. Saya tak ingat adalah in one of this ni. This is the first mark, this is the second mark. So kalau it is a 2-mark question, then that is the answer. There are free moving ions to carry electrical charges. That's why they have to be mobile untuk carry the electrical charges. Okay? Okay. Then write formulae for all ions present in lead to bromide. Lead to bromide is PbBr2. So the ions are
PB2 plus.
Pb2 plus?
BR minus.
Yeah. Macam tu. Dia nak formula, so you tulislah formula. Okay? Ni nampak ni. Kalau orang yang tulisan kecil, nanti tak nampak charge tu. Kesian kat awak. Jadi tulislah besar. Okay. State the observation at the cathode. Okay, kita kata tadi, now we are still at the diagram 4.1. So we see it just now. This is the anode, the one that is connected to the positive terminal of the battery. This one is the cathode, the one connected to the negative terminal of the battery. You have the PbBr2, and so we have Pb2 plus and Br negative. So Br negative will go to the anode, Pb2 plus will go to the cathode. Okay, so then dia kata, okay, what happens at the anode? Electrolysis ni, one thing is, it's a process that you have to understand what happens. At the anode, whoever sits at the anode, that's the one yang akan donate electron. So once, cara nak tulis, here dekat sini, possible untuk dia give you an electrolysis question of molten and they don't give you the E0 value. Kenapa? Because there's no need to choose kan. That's the only one. So dekat sini they can ask you for the half equation. Okay, to write the half equation, Br negative. This is a negative sign. Ada berapa? 1 je kan? So tolak 1 elektron. You write dulu. And then you dah tolak dia punya charge kan? Dah tak ada charge, dia dah jadi atom. Okay. Tetapi as we know, halogen ni they are pengecut. they have to be berdua. So kena ada berdua. Berdua. Okay. Then orang kimia, they don't like negative symbol. Ni tak suka. Humbanlah negatif 2 elektron tu ke kanan. So if you humban dia ke kanan, dia jadilah satu yang positif. So that's how you write the half equation. Kenapa nak tulis half equation? Then only we will realize what is the product. Product here is bromine gas. Okay, which is brown in color. Okay, that one is the thing that happens at the anode. So tadi, this bromine, dia dah buang elektron dia. So what happens to the electron? It will flow through the wire. It will come to the cathode. Who is at the cathode? Ada Pb2+. So Pb2+ will do what? Dah orang bagi elektron, kita ambil. So it will take the electron. Dia dah ambil tu, dia jadilah atom. So this is the product. Okay? This is a metal. All metals basically, 99% of them are what color? Metal.
Grey.
Grey. So you will see grey solid deposited or forms or apalah. Okay? Then you nak tulis the half equation, you dah ada pun. Because I normally tell my students to write the half equation. From there, you can write whatever is the thing that that is produced. So Pb2+ plus 2 electrons, Pb. So this electrolysis, you have to understand the story. Storynya starts from the battery though. So you label the anode, cathode, who goes to the anode, who goes to the cathode. And then what does the anion at the anode do? Dia akan donate electron. And then once it donates the electron will flow in the wire, go to the cathode. Siapa nak accept the electron? It will be the cation at the cathode to accept the electron. Okay, so now kita go do the same thing for the other one. The second diagram ni, diagram 4.2. Again, this is the positive terminal, negative terminal of the battery. So this is the anode. This is the cathode. Okay. So which one is the anode? Is the X lah. Betul. Okay. Dekat sini they will give you lah the E0 values. Okay. Kalau kita tengok kat sini, we have Cu2+, sulfate, hydrogen ion and hydroxide ion. Okay. So tadi siapa pergi ke anode is the negative charge, those with the negative charge. So hydroxide and also sulfate will go to anode. Who goes to the cathode? It will be the positive charge. Ni positive sign dua ni. So dekat sini, then you refer to your E0 values. E0 values tu hydroxide dengan sulfate kan? So we have hydroxide. Where is hydroxide? If anybody can see hydroxide. Ni. Hydroxide is here. It's normally the hydroxide lah yang kita akan nampak. Because kenapa ada hydroxide? Because there is the water there. So we have the hydroxide. Ini. Okay. And also the sulfate. Where is the sulfate? Sulfate kat bawah ni. Okay. Dekat anode, you choose the more negative atau less positive. So more negative is this one or less positive is this one kan? This value kan? So that's why kita pilih hydroxide. So if you have chosen hydroxide, then that means the product is oxygen gas lah. Boleh ke? Can you follow?
Yes.
Okay. So state the observation. So if we know that the oxygen gas is released, okay, obviously dia tak akan keluar name tag dia oxygen. So your observation is?
Gas bubble.
Yeah, gas bubbles. This is the correct term. It's gas bubbles ya, bukan air bubbles. Kenapa bukan air bubbles? Do you know? Sebab air is udara. udara kita consists of nitrogen gas, oxygen gas, carbon dioxide gas, entah apa-apa gas lagi. So, but then this one only has oxygen sahaja. So, oxygen is a gas. So, the term that you use, the istilah that you use is gas bubbles, not air bubbles. Clear ke?
Clear.
Okay. Then the half
Yeah.
equation, ini saya rasa mesti your teacher ada cara untuk ingat. Ada ke Kak Zah?
Ada.
So,
Tanya dia orang Intan.
yeah. How do you remember? Saya nak guna to my students. Okay. How do you remember this one?
4 orang hutan minum 2 botol air.
Mhm.
1 biji oren, 4 biji apple.
Okay. So then you are senang already lah. So you can remember. 4 orang hutan minum 2 botol air, 1 biji oren dan 4 biji apple. So I will remember
Orange
that.
2 biji Intan. Orange kena
Orange
2
2
biji.
biji. Alright. Okay,
Ah.
baik. So then, so bagus kan? Your teacher has already made life easy for you. Okay. So then diagram 4.2 carbon anode is replaced with copper. What have they done here? They have changed that this is an active electrode. So if it is an active electrode, it only affects the anode sahaja. Okay. Sebab tu dia tanya, state the observation at the anode, give the reason. Okay. In this case, instead of carbon electrode now, dekat sini, dia nak ganti ni, dia nak ganti dengan copper electrode. Okay. So remember dekat jadual tu tadi, if it is a copper, here. If it is an active electrode dalam silibus you setakat ini, there's only copper and silver sahaja they will use. They won't use pelik-pelik punya. Kalau inert setakat ni yang dia orang guna is carbon. Okay, selain daripada carbon sebenarnya the inert ones are graphite. Graphite tu sebenarnya is actually carbon lah. And also platinum. Tapi siapa guna platinum? Dekat universiti pun tak guna platinum as the electrode. Okay, so anyway, so this is an active electrode. So bila it is an active electrode, you don't choose the ions anymore. Is the anode itself that will donate the electron. Dia yang semangat nak derma. So that will happen. So bila electrode derma electron, donates the electron. If you derma duit in your pocket now ada RM1,000, it will be tebal. So now once you have donated the RM1,000, what happens to your pocket? Nipis. So that is your pemerhatian. So the anode becomes thinner. Allahu Akbar. Ada orang tulis kurus. Tak boleh tulis kurus ya. The istilah in Malay is nipis. Kalau you tak ingat the word thinner or tak ingat the spelling pun, you tulis anode becomes nipis, that one is accepted. Okay. Ini ramai orang akan marah saya. Tetapi my advice always to my students is, if you tak ingat the istilah, tak boleh nak tulis the whole thing in one language, you boleh tulis the ayat in campur-campur bahasa, except jangan buat dalam satu istilah sahaja. That's why saya sebut kat sini, anode becomes nipis, boleh terima jawapan ini. Diorang akan terima, they will tick your answer. Yang you tak boleh campur-campur bahasa, contohnya potassium, tiba-tiba yang ini klorida. Had ni tak boleh. Ini campur bahasa dalam satu istilah, ini campur bahasa dalam satu ayat. Dalam satu ayat, diorang masih akan mark your answers. Rather than leaving it blank, you might as well write it this way. Clear ke? Tapi ramai cikgu akan marah saya lah. Tapi memang macam tu. Okay, boleh So why is it that why you say the anode becomes thinner?
Lost electron.
Okay. Bila you nak terangkan anything related to electron, silalah guna perkataan atom. Kalau you tak nak guna perkataan atom, then you can say copper ionizes ataupun copper is oxidized. Tapi when you want to explain related to atom, related to electron, sebab you nak kata dia lose electron kan, it has to have the word atom. Copper atom lose or donates electron. So whenever your explanation has got the word electron there, kena ada perkataan atom. Ini banyak murid, even the A+, set A+ pun ada masalah ni. When do you use this? Kita digress sedikit. When do you use this? In chemical bond question. Orang akan miss out marks on this. Lepas tu explaining the inertness of group 18 elements. What you will tell is this argon apa semua ni achieved stable electron arrangement, betul tak?
Betul.
Dekat situ you have to have the word atom. Maksudnya katalah the question says why is argon an inert element? Soalan dia guna element. Tapi in your explanation you will use the word atom. Argon atom has achieved stable octet electron arrangement. Kenapa nak guna atom? Sebab your explanation has got the word electron there. So whenever you see this word, dia mesti couple dengan this fellow. Okay. Kalau tak nak depa ni, gunalah the first ayat ni. Copper is oxidized.
Kalau tulis CU je?
Boleh. Tapi kalau CU tu atom, kalau nak guna untuk elektron masih kena ada atom. Gitu. Clear ke?
Boleh.
Okay. Alright. So electrolysis okay. Electrolysis saya rasa you can answer already kot. Boleh ke? If there are any more electrolysis questions, electrolysis is another one yang orang kurang nak jawab. We go into rusting. Boleh? 1.6. Ya, ini typical redox questions lah. Okay, so question is, this is 2015. Cuba flip through. Okay, iron rusts when exposed to air and water. Okay. When different metals Q and R are in contact with iron, they will affect the rusting of iron. By using suitable examples for metal Q and metal R, describe an experiment to show the effect of different metals on the rusting of iron. Given that Q is more electropositive than iron, okay, and R is less electropositive than iron. Okay, so they want you to use ni, kalau perasan, they want you to give example. So maksudnya they actually want you to determine what is Q and what is R first. So you nak guna Q ni apa?
Zinc.
Kalau boleh zinc. Kalau tak nak guna zinc?
Magnesium.
Okay. Kalau tak nak guna magnesium?
Aluminium.
Ya.
Aluminium.
Itu je. Okay, either one of these three lah. Okay. Tapi in your answer, ini satu benda. In your answer, I know a lot of things you have a lot of knowledge in your kepala, but tulis satu sahaja. If you decide to choose zinc, tulis zinc sahaja. Okay, don't use all. Sebab manalah tahu you yakin sangat benda tu betul, actually it is wrong, it will be WCR for you nanti. Naya je. So then R is
copper.
Something that is yes. So copper is the favorite lah biasanya. Kalau tak nak guna copper, you can use lead, you can use stannum. In your textbook, this one is very clear sebab it is all in one page sahaja diorang terangkan benda ni. Well lah, it's the last. We are here. Okay, here. Dia terangkan kat sini je. Dia ni Ambil. Ini semua yang more electropositive than copper, than iron. This one are all the less electropositive than iron. So you tengoklah your textbook. Okay. Okay, so going back to this, katalah you choose like that. Sekejap ya. SPM 2015. Okay. Then kita dah determine the Q and R. Okay. Pada tahun tersebut, mereka agak macam stingy sikit in terms of the markah. These two will get you the first mark. Okay. Then procedure starts the second mark lah. Okay. Boleh imagine tak macam mana benda ni? Okay. Kalau tak boleh imagine, you draw at the side there. Okay. Cuma dalam kimia ni, even if you draw, it's not like physics, unfortunately. Kalau kita draw pun the diagram, drawing of the diagram does only helps in writing the procedure, but they will not give you marks based on the diagram if they did not ask you to draw. Clear ke? Clear ke?
Yeah.
Okay. So maksudnya, if you can imagine this, you have a nail, iron nail. Lepas tu you kena coil it with metal Q1, another one. Okay, that means you have a second test tube. Okay, you coil it pula with metal R. And then this nail ni mesti immerse dekat dalam a solution, a mixture containing a lot of things. Okay, nanti kita akan tulis. Okay, so the first thing that you will do when it involves metal is to clean the metals with sandpaper. Yang orang selalu terlupa is the fact that iron nail is also a metal. So therefore, iron nail pun needs cleaning. So what you can do is, you can write there, clean iron nails zinc and copper using sandpaper. Okay. Okay, number 3. Lepas tu you nak kena coil. Coil the iron nails with zinc and copper respectively. Kalau you nak tulis, coil the first iron nail with zinc, full stop. Coil the second iron nail with copper pun boleh. Okay. Point number 4. Point number 4 is this is the mixture yang orang akan tersalah eja. So be careful lah spelling. For a mixture of hot jelly. Okay. 3 drops of, yang ini yang orang salah eja, potassium, ni okey lagi, hexa, cyano, ferret is with double R. Berapa nombor dia? 3. Potassium, hexa, cyanoferret, solution. Kalau you use Malay language, dia tak ada double R. And who tadi? Kita nak eja phenolphthalein, pH, phenolphthalein into the test tubes. Betul. Into 2 different test tubes. Okay, sometimes you can, kalau practically-nya, if I were at school in the lab, I would put in the nail and the coil, the coil nails into the test tube first, then only put in the mixture. So the point number 4 and the point number 5 that I'll be writing ni, it is interchangeable. Maksudnya you can tukar kedudukan dia. Okay, so then put the coiled mils into separate test tubes. Sorry ya, my handwriting macam ni sekarang. Nanti you will get the mark scheme yang properly typed. Okay? And then you have to leave the apparatus. Tahu kan, if this were to be done in the lab pun, you have to leave the apparatus for 3 days. Okay? Nak tulis 5 days pun boleh lah, no problem. Okay. For the observation, nanti I will show you the actual how it looks like. Mesti your teacher pun pernah tunjuk you. Okay. For the first test tube, yang ada zinc and iron. Yang ini is copper and iron. What will you be observing for the first test tube ni? Dekat sini dah masuk the observation because they want the observation kan? Hello? Hello? Okay. Okay. So what would your observation be for the first test tube?
Pink spot.
Pink spot lagi? Ada anything else tak? Tak ada kan?
Ada.
Okay. So pink spot. Kenapa ada pink spot?
Ada alkali.
Ada alkali sebab?
Rusting.
Okay. Apa ni? Do you understand the concept of rusting kat sini?
Not quite.
Okay. So what happens is, okay, dalam situasi ini, the first test tube ni, you have zinc and you have iron. Okay. Zinc is more electropositive. Okay. Because it is more electropositive, we can anggap dia macam orang kaya. So this zinc will be the one donating the electron, so it will become the ion. So what does iron do? Dah orang lain dah derma elektron, dia tak payahlah buat apa-apa, dia duduk diam-diam sahaja. So that blue spot will only be present if you have iron 2 ion. Iron 2 ion ada, baru ada blue spot. Since iron tak derma electron, nothing happens to iron. This one doesn't happen. Okay. But then, tengok zinc ni, it has donated its electron kan? Dia mesti ada somebody accepting it. That's why in rusting, dia mesti ada air and water. Kenapa? Because those are the things that will be accepting the electrons. So the air, oxygen, and water will accept the electron and will become the hydroxide ion. Okay, so ini yang you hafal tu tadi. So the hydroxide ion present sebab this oxygen and this water accepts the electron from whom? From zinc. Okay, so that's why ada hydroxide ion. Ada hydroxide ion means ada pink spots. So sebenarnya whoever pun donate electron, be it zinc ke iron ke, pink spots ni mesti ada. Contohnya, kat mana saya letak dia? Kejap ya. If I can show you. If I can show you the gambar of the actual, this is the actual experiment that was done in 2019 sebab gambar ni terlalu cantik, so saya still keep it until today. So if you realise, tak kisahlah whoever yang undergoes the oxidation, the pink spots mesti ada. Okay? Cuma, sometimes in practical, dalam eksperimen, you may not see the pink spots sebab that pink spot tu dah combine with the ion, the positive ion that forms. Tapi in this case, I managed to capture that there are pink spots in each and every test tube. So, which means memang ada berlaku pengoksidaan tu and also berlaku penurunan itu. That is oxidation, that is reduction. So that oxygen and that water tu undergoes reduction sebab dia dah accept electron. That's why there is the hydroxide ion present. That's why you can see the pink coloration tu. Okay, macam dalam case ini, like we said, that this is the same exact situation as in the question just now kan, the first and the second test tube. Okay, the second test tube is the Q tu kan. There's no blue spots. Kenapa there's no blue spots? Because it's the zinc that is donating the electron that is oxidized. Zinc yang akan derma elektron, zinc yang mengalami pengoksidaan becoming zinc ion. Okay. Ferrum ni, iron ni buat apa? Dia tak buat apa-apa. So, there's no iron 2 ion present. So, there's no blue spots. In the case of iron and copper, iron being more electropositive, whoever that is more electropositive, dia lagi kaya, dia yang akan donate electron. Okay, so that means iron will be the one oxidized. When iron oxidized means it will form iron 2 ion. That's why we can see the blue spots here. Clearer ke? Ke lagi pening?
Yes.
Yes lagi pening ke? Oh, faham. Okay. Okay, so dalam case ini, so you will not see blue spots dekat dalam the first test tube. You will only see pink spots. Okay. Dalam the second test tube, what will you see?
Blue spot.
Saya tulis tak habis ni. Pink spot in test tube containing FeNZn. Macam tu. Okay, or iron nail coil with zinc. Or kalau you siap-siap label dah dia tu test tube 1, then senang sikit. Okay. Okay, then this one ada blue and pink spots. Dekat sini, the pink spots is not necessary to mention because that's not the focus of this test tube. So, yang pentingnya dekat this second test tube adalah you put the word blue spot tu. Okay, in test tube containing iron and copper. Macam tu. Okay, why? Okay, point number 9. Sebab dia 9 marks kan? So you have to have conclusion. So dekat sini, basically when iron is coiled or is in contact with, is in contact with a more electropositive metal, no rusting occurs. Okay? Then when iron is in contact with a less electropositive metal, rusting occurs. Gitu. Okay, boleh. Soalan ni appeared again in, kejap ya, in which year? Saya point out the ones yang selalu keluar exam je lah sebab we have limited time kan, kejap ya. It appeared again in 2018. 2018 yang ada here. Dekat sini. Same exact thing. Cuma you must understand the rajah je lah. You faham tak rajah ni? Cuba tengok properly. What does the one thing about rajah is you have to understand the rajah. What does the rajah tell you? In set 1 to what happens? In set 2 what happens?
Corrosion.
Dekat set 1 ada corrosion.
Berlaku.
Berlaku.
Tak berlaku kot. Allah.
Dia tak berlaku tau. In set 1, okay, tak berlaku corrosion tu. Tak berlaku the rusting tu. Sebab kalau berlaku then they will tell you there. Ini ada. Okay. So if this one the rusting occurs, that means metal Y ni more electropositive ke less electropositive than iron?
Less.
Less. Okay, less. So you understand it lah. So then the X ni tak ada, nothing no rusting occurs. That means iron ni selamat je dekat bawah ni. So then X is
More
electropositive than iron. So then you choose lah. This is back to the same thing. Tengok the question based on diagram 9.2 suggest metal X and metal Y. Explain the difference in the observations. So basically you are, kita tengok jawapan teruslah This is in 2018. Okay. 2018. Dia nak the X, nothing happens to the iron. Iron tu selamat. Maksudnya X is something that is more electropositive than the iron. So magnesium, zinc, aluminium. Again, Y is copper or lead or tin. Okay. Then they ask you to explain the observation. Okay. So to explain the difference in the observation, first you tell dulu lah what happens. That in set 1 iron tu does not rust. You don't see rust, dia tak label pun rust. Okay, in set 2 iron rusts. Okay, kenapa? Then you can tell lah based on the electropositivity or based on the E0 value. Okay, so in that case, kenapa iron tak rust? Sebab X yang oxidized. X is the one donating the electron. In the case of set 2, kenapa there is the rusting? Kenapa ada rust? Sebab iron tu yang oxidized. Okay, then again they ask you the same thing to do the experiment, describe the experiment. Bila dia minta describe the experiment, that means they want you to write the procedure and the observation lah. It's same exact thing.
Cikgu.
Ya saya.
Hot jelly solution ni yang mana satu kan?
Agar-agar yang awak makan tu.
Oh, agak-agak. Okay.
So kalau nak buat, kalau nanti pembantu Mak Melayu akan buat, dia akan ambil agar-agar yang kerah-kerah tu, yang macam soun tu. Lepas tu they will masukkan air, panaskan dia, buat macam exactly macam buat agar-agar, cuma tak payah tambah gula, tak payah tambah sirap. So instead of tambah gula and sirap, dia tambah ni lah, potassium hexacyanophthalate 3 solution. Kalau you tubuh terlebih, dia jadi yellowish. Okay, and then phenolphthalein. Phenolphthalein is colourless. So you will see that thing is slightly yellowish lah asalnya. Okay?
Cikgu.
Ya saya.
Kalau phenolphthalein tu kita tukar kepada naoh boleh?
Tak boleh. Sebab you won't see the colour change. The reason why we put in phenolphthalein, sebab you takut spelling the reason why we put in phenolphthalein is because kita nak bagi nampak the pink spots tu. Only phenolphthalein can give you the pink spots. Okay ke? Nanti kalau kita letak sodium hydroxide, you won't see the colour change that is intended tu. Boleh? Dan rasa overwhelmed sangat ke dengan rusting? Okey ke? Okey. So
kan,
dia
sebab tajuk ni dibelajar secara online. Lepas tu tak
Ya.
sempat lagi buat eksperimen.
betul.
Jadi memang
tak nampak sangat.
kita aja setakat kefahaman lah.
Ya,
Yang mana
betul.
yang faham lah, yang tak faham memang tak faham.
Look online, ada so many videos. I used to have a channel with so many videos, and unfortunately YouTube dengki, so they have closed that channel. So I cannot bring you to my channel yang ada benda-benda tu dah pun. So previously memang ada lah. Memang ada eksperimen yang ada gambar just now tadi pun memang saya put there apa semua. So kalau you can use konsep saya with my students pun, you can learn from anyone. Be it your friends, your teachers or whoever yang online tu, as long as you can get the knowledge boleh je. Make sure it's not yang salah lah. So there are so many online yang even JPN Perak pun buat channel untuk amali eksperimen. Carilah dia. So many groups cikgu yang buat eksperimen online. So you can tengok kat situ. Memang it is difficult lah online learning. Saya teach my student this one is in January. So you can imagine diorang punya memory sekarang tak tahulah about this one. Okay. So saya rasa you all bolehnya ni. Kan? InsyaAllah. Okay. I don't think we can finish the whole paper. The most of it that I wanted to tell about electrolysis. Before that, kita pergi sikit je about ni boleh tak? Sel kimia. Throughout 2013 up until 2020, hanya ada satu je sel kimia, soalan berkaitan dengan sel kimia. Chemical cell. So this is the one. 2017 has the most, saya rasa the most rajah yang different. Try to look into 2017. Diagram 6.1 shows the reaction occurred in voltaic cell using magnesium ribbon and copper plate as electrodes. Okay. So okay. Okay. So should I stop here instead? Should I stop here instead?
Intan sambung habiskan.
Oh, okay, sambung habis kan? Okay. Okay chemical cell ni pendek je. Dia punya what you need to realize about chemical cell is again about electropositivity and electropositivity lah. Ya, kita tak sebut langsung about electronegativity itu satu misconception. Okay. Metals will never be electronegative. Because electronegative means tendency to accept electron, and metals do not do that. Metals will only donate electrons. So the term that you use is this metal is more electropositive than the other metal. This metal is less electropositive than another metal. Bukannya kita use one is electropositive, one is electronegative when we are talking about metal. Itu satu benda yang kena understand lah. So in a chemical cell, there will be two different metals that is given to you. And then instead of a battery, they will give you a voltmeter lah in the middle. Because from the difference of the E0 values tu yang menyebabkan adanya electric current tu, electrical energy tu. So the first thing for a chemical cell that you need to know is you have to determine which one is the negative terminal and which one is the positive terminal. Okay. Ini satu benda istilah yang macam tak syok sikit in the sense that it is called the negative terminal, but it is the metal that is more electropositive. In terms of the E0, you will have an E0 that is more negative. This is easier seen lah. Nak lebih mudah ambil this. Negative terminal is the metal with the E0 that is more negative. Okay, so kalau you go back into that series tu tadi, you will see that magnesium will have an E0 value that is more negative than copper. Because of that, magnesium is a negative terminal, copper is the positive terminal. Itu benda pertama that you have to determine, the negative and the positive terminal. Okay, one. Okay, and then what happens? Again, the negative terminal ni is the more electropositive metal kan. So that is the one that will donate electron. So whoever sits at the negative terminal, that's the one that donates electron. So that is the one undergoing oxidation. Okay. Bila dia dah donate elektron, dah sampai ke positive terminal. Okay, siapa nak accept elektron? Ini satu lagi misconception yang orang ingat. It's not the metal yang akan accept elektron. Again, metal takkan accept elektron. They will only donate elektron sahaja. Dia tak mau elektron. Dia nak donate. Okay, so yang nak accept electron are the positive ions in the electrolyte. So again, you have to do something like the electrolysis again. So you senaraikan the ions. Okay, so in this case, you have sodium ion and hydrogen ion. They will go to the positive terminal. Okay, macam dalam this particular question, they have already told you siapa yang akan accept the electron is the hydrogen ion. How is it that we know? Sebab dia dah kata dah molecule, hydrogen molecule ni is formed. So definitely lah hydrogen ion is the one accepting electron. So what I wanted to point out was, yang nak terima electron, to accept the electron is the positive ion. Let's say they did not give you the product kat sini, dia tak khabar. Then the ion with a less negative inode ataupun more positive inode will be the one accepting the electron, the one reduced. Okay, that's how the electric current happens. That's why dekat sini when they ask to explain how the electrical current is produced, saya dah change this one into in your context of Kssm, the inode value of magnesium is more negative. So magnesium becomes the negative terminal. Yang inode value of copper pula is more positive. So copper becomes the positive terminal. Okay, so the magnesium will donate the electrons. Magnesium atom will donate or release the electron to form magnesium ion. Atau in your case, you can put magnesium is oxidized. Okay, so then the electron will flow from the magnesium electrode to the copper electrode through the wire. Okay, and then the hydrogen ion, ini you can ganti with H+. Hydrogen ion receives the electron to form the hydrogen molecule. That's how the electric current is produced. Clear kah? Chemical cell.
Yeah.
Clear.
Okay. Okay. So I think I should stop here. You all pun dah penat one whole day of belajar until tonight. So thank you again for listening. So I hope whatever that I've shared, even if it's just 0.001% benefit to you pun dah alhamdulillah. Also thank you again to everyone in staff for jemput saya untuk this session. Saya juga minta maaf jika ada apa-apa yang saya sampaikan yang tak kena gaya, cara saya salah ke, or it makes you more confused. I hope it doesn't happen, that doesn't happen. So hopefully alhamdulillah, hopefully you have learned something from this session. Okay, thank you everyone. Kika?
Lazmi?
Ya, cikgu. Terima kasih diucapkan kepada penceramah kita. Saya harap banyaklah input yang kita dapat peroleh daripada program kita sebentar tadi. Jadi sebelum kita menamatkan majlis kita pada malam ini, diminta semua pelajar untuk membuka kamera untuk kita tangkap gambar.
Tangkap gambar.
Sorry ya, ambil masa lama.
Tak apa, it's okay. Semua buka kamera sebab nak buat untuk kita ambil untuk KPI Okay, semua buka kamera. Fatu Sadiq, Abbas, Hakim, Azfar Muzakir, semua tak buka lagi ni.
Semoga semuanya A+ ya, insyaAllah.
InsyaAllah sebab Cikgu Intan nak tengok juga yang mana satu. Nanti terjumpa Cikgu Intan tegur tau. Dia ni adalah anak murid Madam Julie
Yeah, my physics teacher was Cikgu Julie.
Okay. Alright. Amirul, Hakim. Okay, senyum semua. 1, 2, 3. Alright.
Okay, thank you semua. Thank you everyone.
Okay, terima kasih banyak-banyak Intan.
Thank you Kak. So saya leave dulu ke? Saya leave dulu ya?
Okay, terima kasih Intan. Okay.
Terima kasih.
Cikgu.
Terima kasih.
Cikgu.
Cikgu.
Thank you, bye-bye.